What if the next cyber attack against you isn't launched by a person, but by an AI that can learn, adapt, and strike faster than any human team can respond? In this video, we're diving into the rapidly growing connection between AI and cybersecurity, how artificial intelligence is changing the way we detect threats, protect sensitive data, and respond to attacks in real time. But we'll also look at the other side, how hackers are using AI to create smarter phishing scams, automate attacks, and bypass traditional defenses. By the end, you'll understand why AI is becoming one of the most powerful tools in cybersecurity, why it also creates serious new risks, and what this means for the future of digital safety. So stay with me, because the battle between AI-powered defense and AI-powered attacks is already happening.
We are stepping into a whole new era of cybersecurity, and right at the center of it is this complicated dance with artificial intelligence. So today, we're going to dig into a really strong case for why openness might just be our best and maybe our only defense.
So let's just start with a question that really sets the scene for all of this. What would happen if an AI could not only find a security vulnerability, but actually exploit it? Not in days, not in hours, but in just a few minutes. And believe me, this isn't science fiction anymore. And that's where Mythos comes in. Mythos is a frontier AI, a large language model that has shown it can do exactly that. But here's the twist. Mythos itself isn't the real story. It's really just a proof of concept for a powerful new system for both finding and patching flaws in code.
And that difference between the model and the system is the first thing we really have to get our heads around. The real power here isn't some single magic AI. It's the entire system that's built around it. You know, a model like Mythos, it's just one piece of the puzzle. The true muscle comes from the whole operational system it's plugged into. And if you can grasp that, you're halfway to understanding the new threats we're facing with AI and cybersecurity.
So what's the recipe for a system like this? Well, it boils down to 5 main ingredients. You need a ton of compute power, you need specialized security data to train on, and then you need this custom scaffolding, which is basically the software framework that tells the AI how to attack. Throw in high speed and system autonomy, and what you have is a formula that can be used over and over again. And that's the key. This isn't some one-off magic trick. It's a repeatable recipe, which means other groups are going to build these systems. You can bet on it. This capability is about to be everywhere, and it's happening fast. Okay, so if this crazy powerful capability is spreading, how in the world do we defend against it? Well, this is where we get to the core idea of this whole explainer. The answer might actually be found in a more open, more collaborative approach. I want you to think about software security like a frantic race against time. The second a vulnerability is discovered, the clock starts ticking. You've got to go through 4 stages. You detect it, you verify it's real, you coordinate a fix, and then you propagate the patch out to everyone. In this game, speed is absolutely everything. Now here's where your strategy really starts to matter. If you're in a closed system, one single company is responsible for that entire race, from start to finish. They literally become a single point of failure. But in an open ecosystem, that work is spread out across a whole community of defenders. And that makes the whole process way faster and a lot more resilient. And this just completely flies in the face of that classic argument for closed systems, right? The whole security through obscurity thing. The idea that if you just hide your code, no one can find the flaws. In the age of AI, that thinking isn't just outdated, it's becoming downright dangerous. And here's exactly why. Modern AI tools are getting scarily good at reverse engineering closed, binary-only code. So all of a sudden, that mountain of unmaintained, forgotten firmware that's in millions of devices, it just became a massive, wide-open attack surface. Those walls of obscurity are basically turning to dust. But the threat isn't just from bad guys on the outside. There's a new, more subtle danger brewing, and it has to do with how AI coding tools are being used inside companies with closed-off code bases. What happens is this really dangerous 3-part problem. First, these AI coding assistants, which are designed for speed, start introducing more bugs faster than ever before. Second, all these new flaws are buried deep inside a proprietary black box. And third, that means only one team, the company that made it, is responsible for finding and fixing everything. This creates this huge imbalance. You've got AI-powered attackers from all over the world hunting for a growing pile of hidden bugs, but only one single team is playing defense.
That gives the attackers a massive and, frankly, a terrifying advantage.
So, if closed systems create such a dangerous situation, how can we actually use open AI to fight back? Well, the answer is all about building systems that put human beings firmly and transparently back in control. This is where something called semi-autonomous agents come into play. Now, these are not the kind of AI systems that can just go rogue. Instead, the actions they can perform are very clearly predefined, and for the most critical steps, a human has to give the okay. It's really the sweet spot between getting the benefits of AI without taking on unmanageable risk. And this approach has some huge benefits in the real world. People always stay in the driver's seat, with the AI acting more like a superpowered assistant for very specific jobs. And here's the best part. Because these systems are built with open parts, a company can run it on their own private servers with security controls they can actually customize and trust. There's this quote that just absolutely nails it. The human in the loop is only meaningful if the human can see into the loop. I mean, what's the point of having a human supervisor if they have no idea what the AI is actually doing under the hood? It's just security theater at that point. And that gets right to the core of this argument for openness. That kind of real transparency, the ability to truly see what's going on, is only possible if the defensive systems you're using are built from open, auditable parts. You need open scaffolding, open rule engines, and clear, detailed logs that a security team can actually dig into and verify for themselves. Okay, so let's zoom out and look at the big picture here. When we think about the path forward, it becomes pretty clear that making our digital world safer isn't about finding one perfect tool. It's really about building the right kind of ecosystem. We have to remember something really basic about cybersecurity. The attackers don't work alone. They have their own communities. They coordinate, they share tools, they share techniques, they work together to get better. So the defender's playbook has to be just as collaborative, probably even more so. We're talking about things like open security reviews, publishing our threat models, creating shared vulnerability databases, and maybe most important of all, building open tools that any team anywhere can use, adapt, and improve. So what's the big takeaway from all this? The future of cybersecurity isn't going to be decided by some secret magical AI model that's locked away in a vault somewhere. It's going to be shaped by the health, the transparency, and the collaborative power of the defensive ecosystems that we all choose to build. Which really just leaves us with one final critical question. As AI makes both offense and defense exponentially more powerful, is security a race we can really afford to run alone? Or is it a race we can only win if you run it together?